Breathing, one of the most important tasks that we perform every single minute of every single day. So, how does this amazing machine that we call human body performs this task? And how much control do we have over this task? Hey guys, welcome back to my channel. I'm Meghna Menon and today we're going to be learning about the respiratory system. So, I'm pretty sure that you weren't thinking about your breathing and you probably are now. So, we've got a lot to discuss. So, let's take a deep breath and let's begin. So, over here, we are not learning about cell respiration. We are only learning about normal breathing. So, we can breathe from our nasal cavity and our oral cavity too. So the advantage in breathing from our nasal cavity is that there are lots of hair, small hair and mucus which make the air warmer and they trap all of the pollen grains, all of the dirt, and they just remove it out so that we don't breathe that dirt. Then we breathe from the oral cavity, from our mouth when we do a lot of exercise and we need more oxygen, like we are running and we need more oxygen. That time we breathe from our mouth. Or in CPR. So CPR is a life-saving process. So in that the air, oxygen you can say, can only be passed from the mouth to the lungs. So both the nasal and the oral cavity meet at the pharynx, and from the pharynx they go to the larynx, and from the level of the vocal cords they are divided into two pipes, the trachea and the esophagus. So you can see that this is the trachea, which is called as the windpipe, and this is the esophagus, which is called as the food pipe. And you can see that the trachea is covered with C-shaped rings which are cartilage. So this is the trachea and this is the esophagus. You can see that the trachea has C-shaped cartilages which are complete in the front and incomplete in the back, which helps the trachea to not collapse and give some space to the esophagus when the big bolus of the food comes down. And there is this flap-like structure called an epiglottis. So it just closes the trachea when we are swallowing. So that is why we cannot breathe while we are swallowing. So you can see that here is the trachea and it is being divided into two bronchi. The bronchi is going into the lungs, and the bronchi even has C-shaped cartilages, and the bronchi is further divided into bronchioles, and the bronchioles don't have any C-shaped cartilages. So you can see that the most important organ we are coming to now, which is our lung. So you can see that our lungs are divided into lobes. Our right lung is divided into 3 lobes and our left lung is divided into 2 lobes because it has to give space to the heart. Just like our heart, our lungs are covered with 2 membranes called as pleura. Between these 2 layers, there is a fluid called as pleural fluid. It helps in lubrication. So, our lungs are made up of balloon-like structures called as alveoli. So, when the impure blood goes from the pulmonary artery to the lungs by small capillaries, the exchange of oxygen and carbon dioxide happen from the alveoli, and the oxygenated blood comes back again from the pulmonary veins. So, imagine this balloon like the alveoli. So the alveoli is collapsed and this is the bronchi and there is air in the bronchi, but the balloon is not getting filled with air. To make the balloon filled with air, I need to blow air into it. But we don't breathe in so forcefully that the collapsed alveoli can be filled with air. So what helps in making the alveoli filled with air? Come on, let's go! So, our ribs have intercostal muscles as well as many other muscles which help the ribs, like when we breathe, they help the ribs to come out and go upward. And there is one more really important skeleton muscle called as the diaphragm. It divides the abdominal and thoracic cavity. So you can see that the ribs are going down and they come back up to join with the sternum, and I'm going to use a very humble bucket to show you all that how the movement of the ribs made some space in the chest cavity. Imagine that this is the ribs. The only difference is that the lungs and the ribs are connected to each other, and these are the lungs. So now you can see that when the ribs go outward and forward, they make a negative pressure in the cavity and they give some more space. Let me show you how breathing in and breathing out happens. So this is the model. So you can see that I have made a trachea and the bronchioles using this straw, and the pink balloons that you can see are our lungs, and the white balloon that you can see is our diaphragm. As you can see that the pink balloons right now are in the collapsed form. So when we breathe in, our ribs go outwards and upwards and the diaphragm goes downwards. This creates more volume in the chest cavity and decrease of atmospheric pressure in the lungs. So you can see when the diaphragm is pulled down, the air that was trapped in the trachea gushes in to the lungs, making the lungs filled with air. And when the diaphragm goes back into the dome shape, you can see that the lungs collapse again. Breathe in, breathe out. Breathe in, breathe out. So the intercostal muscles and the diaphragm do all the work, but the lungs get all the credit. So sad. Anyways, these all have to work in sync to help us breathe in and breathe out. So keep your lungs healthy and try to decrease the pollution, and nowadays always do breathing exercises, and don't forget to like, share and subscribe. Bye.